Hi! The Hall County School District is excited to announce the release of our back-to-school ELA and Math Reconnect broadcasts. Between August 12th and August 21st, the Hall County School District plans to release 6 ELA and 6 math video lessons for students in kindergarten through 2nd grade, 3rd grade through 5th grade, 6th grade through 8th grade, and 9th grade through 12th grade. Along with the video lessons, students and parents will have a list of supplemental resources related to the topic from the lesson. Students and parents can have access to these videos and resources on the district's Reconnect Hall website beginning on August the 12th. We hope students and parents find these instructional tools helpful in getting a jump start on learning for the upcoming school year. Welcome, and thank you so much for taking the time to get ready for the new school year in Hall County. The following reminders are super important as you begin working with me on this video. First, use the resources provided to further your learning. Access supplemental resources using the link below the video. Resources that require a connection to your Hall County Google Drive account are noted on the list. Also, make sure you pause the video when needed to think about what you are learning. You may even ask yourself some questions. Do I already know this? Is this new information? Who taught me this in the past? Today, we're going to talk about the Pythagorean Theorem in 8th grade math. We're going to be talking about the following standards. The big idea is that we're going to understand and apply the Pythagorean Theorem. Geometry Standard 6 says, explain a proof of the Pythagorean Theorem and its converse. Geometry 7 says, apply the Pythagorean Theorem to determine unknown side lengths in right triangles, in real world, and mathematical problems in 2 and 3 dimensions. Today, we're going to talk about 2 dimensions. And then Geometry 8 says, apply the Pythagorean Theorem to find the distance between 2 points in a coordinate system, or a graph. You and I are going to work together to tackle the following learning targets, or goals, in this video. So our 3 learning targets for today are going to be to apply the Pythagorean Theorem to determine unknown side lengths in right triangles, determine if a triangle is a right triangle, and solve problems involving the Pythagorean Theorem. Again, remember, don't be afraid to pause the video if you need a minute or two to think. Just make sure you come back when you're ready and finish the lesson with me. Before we begin to really investigate the Pythagorean Theorem and accomplish our learning targets, let's try a warm-up. I want you to substitute in for the following equations. You have a variable x, and I've told you that x equals 4. So I want you to try to substitute in and see if we can find the value of our expressions. So pause the video and come back when you're finished. Alright, welcome back. Let's check these expressions. So if I substitute 4 in for number 1, 3 times 4 is 12. If I substitute 4 in for number 2, 4 times 4 is 16. And then if I take 16 and subtract 12, I get 4. How you doing so far? Number 3, I could do a couple different ways, but what I'm going to do first is I'm going to substitute in 4 and for the x. So 4 plus 4 is 8, and 8 times 3 is 24. You could have distributed the 3 first and then substituted, but I wanted to go ahead and substitute. Number 4, you have a couple different ways you could have solved it too. You could have simplified first because I can combine like terms. 3x minus 2x is 4x. And then if I substitute in, 4 times 4 is 16. Could have also substituted in both of the x's. 6 times 4 is 24, minus 2 times 4 is 8, and 24 minus 8 is still 16. So no matter which way you did it, you should still come up with 16. Alright, so we're going to get started because the Pythagorean Theorem, we're going to have to substitute in some values and solve, so this will be a great warm-up for us. Alright, let's talk about our mini lesson. Let's get into the Pythagorean Theorem. So the first thing is we need to talk about what a right triangle is. Well, the picture is showing you what a right triangle is. A right triangle has a 90-degree angle. One of the side lengths has a special name. We call it the hypotenuse. And the longest side is the hypotenuse, and that's always opposite the 90-degree angle. So if you look at our picture here, you've got the 90-degree angle here. Side C, or the hypotenuse, right over here, is going to be the longest side. These other two sides, A and B, they're both called legs, and either one of them could be A and B. So those are the other two are legs, and then C is the hypotenuse. And Pythagoras developed a formula for finding the length of the sides of any right triangle. So one of the big things I want you to remember today is that this only works for right triangles. If it's a different kind of triangle, if it doesn't have a 90-degree angle, this formula is not going to work for it. All right, so what is the Pythagorean theorem? That's what we're going to be talking about today. So while I'm talking, I want you to check out the video that's playing, and it's a proof of the Pythagorean theorem. So you can see that things are breaking apart and fitting in together. So I want you to watch that for a few minutes. The Pythagorean theorem says that for any right triangle, remember right triangle, the sum of the areas of the two small squares is equal to the area of the larger square. So basically what it says is that the squares that sit on the side lengths of the legs add together to equal the square that sits on the hypotenuse. So if you see that one leg is breaking apart, it's going to fill in the square of the hypotenuse except for the middle section, and the other leg's square fills it in perfectly. So this is proving that the Pythagorean theorem works. Well, let's watch it with water. That means that if the areas of the squares that sit on the smaller side lengths are added together, you're going to get the area of the square that sits on the hypotenuse. So if you watch as she turns this, the water starts out in the smaller two squares and fills up, and then they go together to fill up the bigger square perfectly. So A's square plus B's square equals C's square. So if you want, you can always come back to these slides and watch the proof that this Pythagorean theorem works. All right, we're going to watch a brain pop to kind of introduce us to Pythagorean theorem. So let's check out what Tim and Moby have to say.
Measure twice, cut once. Dear Tim and Moby, can you explain the Pythagorean theorem? From Carrie. Sure thing. The Pythagorean theorem applies to right triangles like this one. Every right triangle has a right angle. That's any angle that measures exactly 90 degrees. The side opposite that right angle is the hypotenuse, and the sides adjacent to that right angle are called the legs. The Pythagorean theorem says that the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. Yeah, it's named after the Greek mathematician Pythagoras, who's often credited with coming up with the equation. In truth, it was probably known to mathematicians before him, at least in part. But Pythagoras got the credit for some reason, so here we are. Okay, let's try it out. C is our hypotenuse. We can plug in 5 for that, and we know that 5 squared is 25. Leg A measures 4 centimeters, so A squared is 16.
Now they're
and
substituting
B
in.
is 3 centimeters, which makes B squared 9. 16 plus 9 is equal to 25. We just proved the Pythagorean theorem. We can use the Pythagorean theorem to find the length of a right triangle's leg as long as we know the lengths of the other leg and the hypotenuse. 10 squared is 100, and 6 squared is 36. We subtract 36 from each side, which gives us 64 equals B squared. B equals the square root of 64, which is 8. So leg B is 8 centimeters long. Pretty cool that the Pythagorean theorem works, eh, Moby? Wow. Look at all those toothpicks you made. You know they sell those in stores, right? That's true. These are made of nicer wood.
All right. So, they reminded us that a squared plus b squared equals c squared. 2 legs and a hypotenuse across from the 90-degree right angle. So we're going to get started doing some practice. So let's look at this again. I want you to see that I've got some individual squares drawn out for you so that you can really visualize this. So this side is a leg, the 9. Where the 9 is, that's a leg. The side length of the yellow square is 3. The area of the yellow square is 9. So you can see that the side length of the triangle is 3, but the area of the square is 9. And remember, that's what helps us with the Pythagorean theorem. Look at the blue leg. This side is also a leg. The side length of the blue square is 4. The area of the blue square is 16, because 4 squared is 16. So we have 3 squared is 9, 4 squared is 16. This side is the hypotenuse across from the right angle. The side length of the red square is 5. You can see, here's the side length, it's 5. The area of the red square is 25. So if I look at this, I need to make sure that I see the difference between the side lengths and the areas of the square. Side length is 4, 16 squares. So if I individually counted these squares, there would be 9. If I individually counted these squares, there would be 16. Same thing here for 25. That's why the square works. So based on the Pythagorean theorem and what we can see from this picture, a squared plus b squared equals c squared. So the area of the legs, right? The area, not just the side length, the area, 9 plus 16 equals the area of the hypotenuse. So the yellow square plus the blue squares equal the red square. All right, how are we feeling? We got it? Or do we need to go back and review? If you got it, keep going forward with me. If you need to go back and review, feel free to rewind the video and do that. One question, what if a squared plus b squared equals c squared isn't true? What if it's not working? Well, if the squares of the side a and b do not equal the square of the side c, then it can't be a right triangle. So I want you to look at this example. Pay attention, this picture is the same picture that we looked at earlier. So if the angle, or the measure, of A, this leg, is 4, B, it's telling me, is 6, and C is 10. Here's my formula. A squared plus B squared equals C squared. I'm going to plug it in. A is 4, B is 6, C is 10. 4 squared is 16, 6 squared is 36, and 10 squared is 100. Well, 16 plus 36 is 52 equals 100. Does it? No, it doesn't. So if these were my side lengths, then it cannot be a right triangle because the Pythagorean theorem is not true in this case. This video is linked in your resource document. Go through and check it out. It provides you some more examples and a little bit more information if you need to go back and review a little more. So let's look at some examples. So the first thing I want us to focus on is to determine the given side lengths if they form a right triangle. So remember, the longest side is always the hypotenuse. It always has to be the longest. So I want you to look at these 4 examples, and the longest side is always C. Then plug in A and B, square them, and see if they equal the square of C. If they do, the answer is yes, it's a right triangle. If they don't, the answer is no. These side lengths cannot form a right triangle. So I want you to pause me, do these 4 quick examples, and come back and we'll check your work. All right, welcome back. Let's look and see how you did. So if you'll look in the top corner here, 24 and 18 and 30. Did those form a right triangle? Well, I said yes. Let's check our work. 24 squared is 576. 18 squared is 324. And if I add those together, I get 900, which is 30 squared. And remember, the 30 has to be the hypotenuse because it's the longest. All right, let's look at this one. 9 squared is 81. 15 squared is 225. And then 12 squared is 144. Now, what is the issue here? Well, the issue is the 15 is the largest. Okay, so it might not be in order every time. 15 is the largest, so it has to be the hypotenuse. So when I'm adding these, I'm going to add 81 plus 144, and that does equal 225. All right, let's go over here to some smaller numbers. 2 squared is 4, 3 squared is 9, and that equals 13. Well, 4 squared is 16, so that cannot be a right triangle, so the answer to that one is no. And then the bottom one here, last one, 10 squared is 100, 14 squared is 196. Well, if I add those together, I get 296. Well, that's close, but 17 squared is 289, not 296. So these three side lengths cannot form a right triangle. So that's how you check to see if it even works. If you're given all three side lengths, you're going to plug them into your formula and see if it makes a true statement. Now that you know how to prove if the triangle is a right triangle, let's see if we can find some missing side lengths. So this is going to be a review of what Tim and Moby did as well. So we're going to plug in values. We're going to be missing one value, and we're going to solve for it. All right, so you're going to find the missing side length of each right triangle. Side C is the hypotenuse. Sides A and B are the legs. I want you to remember that as you're plugging them in. So look, A and B, we're going to solve for C here. But down here, we're going to have to do some subtracting and solve for B. So pause me, work these problems out, and then come back and we'll check your work. All right, welcome back. Let's see how well you did on solving for the missing side length. Now the biggest thing is you got to make sure you square and do those things correctly. So let's see what we figured out. All right, A equals 5 centimeters, B equals 12 centimeters. Our answer is C equals 16 centimeters. So when we did, or sorry, not 16, 13. So that was a perfect square. Down here, A equals 9 miles, C equals 15 miles. We're going to subtract it. 225 minus 81 is 144, and that leaves me with 12 miles. Down here, A equals 8 centimeters, C equals 17 centimeters. So when I subtract the 64 from the 289, I get 225. And the square root of 225, it's a perfect square of 15. If we look at this one here, we're going to solve for A. So this is 100, and if I subtract 64 from it, I get 36, and the square root of 36 is the perfect square of 6. All right, last one we're going to look at here before we go to that tricky one. I'm going to solve for A again. So 5 squared is 25, minus 4 squared is 16, so that's 9, and the square root of 9 is 3. Well, why did we leave this the square root of 65? I'm glad you asked. Well, I'm finding side C, the hypotenuse in this problem. So 7 squared is 49, and 4 squared is 16. 49 plus 16 is 65. So when I take the square root of both sides, the square root of C squared is C, and the square root of 65 is not going to be a perfect square. So depending on what your teacher wants, he or she might want you to leave it as the square root of 65, or they might want you to simplify it to about 8.1. But they're going to tell you exactly what they want, or so will the problem. So this is just finding the missing side lengths. Let's keep going. Let's talk about the Pythagorean Theorem in the real world. We saw that Tim and Moby were actually doing some construction and using the Pythagorean Theorem. Let's see how else we might use it.
most exciting chases in the NFL. A receiver or a running back making a beeline for the end zone with a defender in hot pursuit.
You identify the ball carrier. From there, you want to close the distance between yourself and the ball carrier as quickly as possible.
They have to choose what direction and speed to run so that they get to the same place at the same time as the runner and can make the tackle.
In football, the path the defender must take to intercept the ball carrier is called the angle of pursuit. According to John Zeigert, an automotive engineer at Clemson University, this path is also a perfect illustration of a fundamental equation in geometry called the Pythagorean Theorem, discovered by the Greek mathematician Pythagoras more than 1,700 years ago.
Pythagorean theorem is a basic theorem in plane geometry or Euclidean geometry that relates the lengths of the sides of any triangle where one of the angles is 90 degrees, called a right triangle.
On a right triangle, the two adjacent sides, A and B, are called the legs. The longer side, opposite the right angle, C, is called the hypotenuse. The Pythagorean theorem simply states A squared plus B squared equals C squared.
The square of the hypotenuse, the length of the hypotenuse, is equal to the sum of the squares of the lengths of the other two sides.
Relating this to football, let's say the ball carrier is heading for the end zone, 40 yards away. The defender stands 30 yards away and needs to intercept him. If these two distances are the legs of a right triangle, then the distance the defender needs to run is the hypotenuse. Using the Pythagorean theorem, 30 yards times 30 yards added to 40 yards times 40 yards will give the length of a hypotenuse squared. To get the actual length, take the square root.
40 squared plus 30 squared is equal to 2,500, which is 50 squared. So the distance of the hypotenuse is 50 yards.
You got to be precise in what you're doing, and you have to take a right angle, especially in coverage.
NFL players must react instinctively to cover this distance and also gauge how fast they need to run to match their opponent's speed.
The defender, now, if he chooses that angle of pursuit, he says, okay, I've got to cover this distance in the same amount of time it takes the runner to cover this distance.
If you're chasing a fast guy, like a Marshall Falk or, some of those guys that can really burn, if you take the wrong angle, you're done.
The defender's angle of pursuit can be the difference between a touchdown and a game-saving tackle. It's also a perfect illustration of the properties of a right triangle and the ABCs of the Pythagorean theorem.
So, how about that? The Pythagorean theorem can relate to football. Let's keep going. Alright, so if a ladder is leaning against a two-story window of a house, see it in my picture? The ladder is 25 meters long, and the base of the ladder is 7 meters from the house. How high is the window? So first, it's going to be important for you to draw a diagram and label the sides with the distances you know. Then, use the theorem to solve for the missing side. So before I let you go, let's look at this together. So here's the length of the ladder. What is it? 25. That's right. It tells me that the ladder is 25 meters long. The next thing it says is the base of the ladder, that's down here, is 7 meters from the house. So this leg down here is 7. And what it wants me to know, or what it wants me to find, is the height of the window, how high it is on the house. So I'm finding A or B, whichever one you prefer. A or B, one of the legs is 7, the hypotenuse is 25. Plug that into your Pythagorean theorem. When you're finished, come back and let's check your work. Alright, welcome back. Let's check out your work and see how you did. Alright, so if I plug in what I know, so in this case, I left A squared as what I don't know. You could have left B. Remember, they're interchangeable. So 7 squared, A squared plus 7 squared is 25 squared. 7 squared is 49, and 25 squared is 625. I'm going to subtract 49 from both sides. I've got a squared equals 576 left here. Well, I'm going to take the square root of both sides. Remember, the opposite of squaring a number is taking the square root. So if I want to get a by itself in solving equations, then I'm going to take the square root to leave a. And the square root of 576 is 24 meters. So what does that 24 meters mean in the context of my problem? It means that the height of the window from the ground is 24 meters. How'd you do? I hope you got it right. Let's go to the next one and see if you can get this one. All right, let's see this one. Jane's TV screen is 5 feet in length and 3 feet in width. The length of the diagonal measures the size of the TV. What is the size of Jane's TV? So let's look at what we have for our picture here. Remember, first draw a diagram and label the sides with the distances you know. Then use the theorem to solve for the missing side. So let's think about the distances we know. We know that the length is 5 feet and the width is 3 feet. So it's a 3 by 5. But we know that the diagonal tells us what size TV we have. So we need to find the length of the diagonal. So it's always important for us to draw a picture so that we can figure out what we're finding. So I want you to pause the video, work it out, and find the length of the diagonal, and come back and join me. All right, welcome back. Let's see how you did on Jane's TV screen. So Jane's TV, remember, is 5 feet by 3 feet. So when we plug this into our equation, we have 5 squared plus 3 squared. Now, some of you may have had 3 squared plus 5 squared. Is that okay? Of course it is, because remember, the legs are interchangeable. So no matter what, the 3 and the 5 are on a side together, and then we're finding the hypotenuse. So 5 squared is 25, and 3 squared is 9. 25 plus 9 added together is 34. That equals x squared, remember, but I don't want x squared. I want the side length, not the size of the number of squares. So I'm going to take the square root of both sides. Well, the square root of x squared is just x. The square root of 34 isn't perfect. So we could leave it the square root of 34. But if we're talking about a real world example, how far is square root of 34? What does that even mean? Well, it's about 5.8 feet. So that is the answer to the size of Jane's TV. You would tell somebody it's a 5.8 foot TV. Okay, let's keep going. All right, Pedro is standing with his hands in the air and is 7 feet from the tips of his fingers, casting a shadow on the ground. The distance from his fingertips to the end of the shadow is 11 feet. So we're going to find the length of his shadow. So remember, it's going to be important for you to draw a diagram. Look, it's a simple right triangle that we've drawn. You can see I've got a little boy standing there. And then we're going to label what we know. So if I label what I know that Pedro is 7 feet high from his toes all the way to the tips of his fingers. And it tells me that it's 11 feet from the top of his fingertips up here to the end of his shadow. So his shadow is going to be on the ground. So that's the value I want you to find. So go ahead and pause me, work it out and find that leg, and let me know when you're finished. Come back. All right, welcome back. Let's see what the length of Pedro's shadow is. So we were given the side length of 7 and the hypotenuse length of 11. So when I plug that in, a squared plus b squared equals c squared. 7 squared plus b squared. Now remember, you could have had a squared plus 7 squared because they can go back and forth. They're interchangeable, right? Can you change out the 11? No. The 11 was the hypotenuse, and it always has to go in for c. 7 squared is 49. 11 squared is 121. So when I subtract 49 from both sides to get that b by itself, remember, I get 72. Then I need to take the square root of both sides here to get b by itself. The square root of 72 is not perfect. So when I estimate it, I get about 8.49 feet. Now what does that mean in the context of our problem? It means the length of Pedro's shadow is about 8.49 feet. All right, here's a little bit of a different one. Let's look at it. Every day, Megan walked from her house to school. She walked east 8 blocks and then turned south and walked 6 blocks. How far away from her house is she once she reaches school? We're going to use the Pythagorean theorem to solve this. Now remember, we talked about always should draw a diagram. So when I'm thinking about that in my mind, I'm going to draw what the words say. So if she walked east and then walked south, my triangle might look like this. So right here, if I start here and walk east 8 blocks and turn and go south 6 blocks, I want to figure out how far she started when she gets at school. So I'm finding that distance of the hypotenuse there. So I want you to pause me, work it out, and come right back. All right, welcome back. Let's see how far Megan is from her house once she reaches school. So here's my triangle, and here's my work. So remember, these are both legs, so I'm finding that hypotenuse, that's c. A squared plus b squared equals c squared. 8 squared plus 6 squared. Could you have 6 squared plus 8 squared? That's right, you could. They're interchangeable, remember. So 64 plus 36 equals c squared. If I add those together, I get 100 equals c squared. I'm going to take the square root of both sides, and I get 10 blocks. So that's how far Megan is from school, from her house. How are you feeling? Making sense? I hope so. If it's making sense, keep going with me. If it's not, go back and check out a video. Look at some examples again to make sure that you're caught up. Alright, we're going to watch one more short video to figure out how we can use the Pythagorean theorem to find the distance between 2 points on the coordinate plane.
Alright, sometimes we're going to find ourselves and we're looking at a graph and we say to ourselves, you know what, I want to get from this delicious looking cake over to this wonderful piece of cheese. Well, I can't read on a graph how far that is. There's no sure way for me to count, well, it's 1, 2, 3. It doesn't work out exactly. So, luckily, we've learned about the Pythagorean theorem. And the Pythagorean theorem is actually going to give us a great way to solve these types of problems. Notice I have my green line here. Well, if I were to make a line down here and then cut straight across, I've now created a right triangle. And I know how to find the distance of my C or my hypotenuse in a right triangle. All I have to do is find out my side lengths, and then I can use the Pythagorean theorem, which remember is a squared plus b squared equals c squared. So let's take a look and see if we can find our side lengths to start. 1, 2, 3, 4. So I have a side length of 4, and I'm going to call that side A. Then I have a side length of 1, 2, 3, and I'm going to call that my side length B.
Could you switch those?
Now that I have those two pieces,
Yes,
I
you
can come
could.
into my formula and figure out my missing information. So if I'm looking, I know that A is 4 squared plus B, which is 3, and then squared, equals C squared. Well, I know 4 squared is 16, 3 squared is 9, and I add these together, and that's going to give me my C squared. Keep it on the same side here, guys. I have a lot of people who want to add that 25 and then put it over where the C's at. Keep it all on one side of the equal sign. It's going to treat it like an equation. It's going to make sure we don't get things mixed up. So 16 plus 9, like I said, is 25, and that equals C squared. But I'm not finished here, right? I don't want to know what C squared is. I want to know what C is. So to get rid of that square, I have to square root it. I do it to both sides. 25, the square root of 25 is 5, and so that is the length of C. And so now I've found out that my delicious looking cake is 5 units away from my fabulous piece of cheese. So that's one way we can use Pythagorean theorem on a coordinate plane.
All right, so what we're going to do is we're going to be able to count on the coordinate grid to be able to move to figure out the lengths of some diagonals. So let's try this together. So if this is what I have, I've got this point here and this point here. You can see them underneath my colored side links there. So we're going to pick a point to start, and you're going to count on the grid to reach the next point. And then you're going to use the two sides you counted for the legs. So in this example, I started at this point. You could have started at this point too. You're going to get the same answer. But if I started here, I counted down the blue line, 1, 2, 3, 4, 5, 6, on the grid 6 spots. And then I counted across to the right 8 spots. 1, 2, 3, 4, 5, 6, 7, 8. So I count my jumps, right? So I've gotten from my green point, sorry, not my green point, my black point, down here to my other black point. I could have counted here and counted 8 this way and 6 up. Doesn't matter. They're both going to be our legs. Okay, so that 6 and that 8 have created the legs on our triangle. Now we're going to use the theorem to figure out the length of the hypotenuse from this point to this point. Okay? What would I do for finding right here? Well, 6 squared is 36. 8 squared is 64. We've done this one before. 64 plus 36 is 100. And the square root of 100 is 10. So the length of units from this point to this point is 10 units. All right, let's check this one out. So you're going to find the distance between the 2 points on the coordinate plane to the right. In this one, I've given you the coordinate points. And that's great. You could count those, and I could do 8 minus 2 and get 6. I could do 4 minus negative 3 and get 7. But it's important, we could also just count them. I could jump up and across, or I could jump across and then down. So the first thing I want you to do is count to get your side lengths. You should have gotten 6 and 7. Okay, so now that you have your side lengths, I want you to think about how you would find the diagonal. All right, so a squared plus b squared equals c squared. 6 squared plus 7 squared. Could you change those up? Absolutely. 36 plus 49 is c squared. Take the square root of both sides. The square root of 85 is about 9.22 units. So those 2 points are about 9.22 units away from each other. All right, so I want you to find the distance between the 2 points on the coordinate plane to the right. So pay attention. I'm trying to get from this point to this point and find it. Remember to create your right triangle and find the length of the hypotenuse. Go ahead and pause me, work it out, and I'll see you in a minute. All right, welcome back. Let's see how we did. All right, we were trying to find the length of that diagonal right there, so I moved 8 units and 6 units for my legs. And that's one that we know that you probably are getting used to seeing that might help you as you move on. 8 squared is 64. 6 squared is 36. Together that equals 100. And the square root of 100 is 10. Great job. All right, let's keep going. All right, the next screen is going to take you to your work session. And if you'll check out your note sheet, you have these on your note sheet as well. So what you're going to do is you're going to find the missing side length of each triangle. Side C is always going to be the hypotenuse. Sides A and B are the legs. If your answer is not a perfect square, for these problems, I want you to leave it as a square root. You don't have to worry about estimating. You can just leave it as a square root. But if it's perfect, I want you to tell me the exact value. All right, so I'm going to go ahead and stop. I want you to pause this. Work out these 10 problems, and we'll see you back in a minute to see how you've done. All right, welcome back. Let's see how you've done on the work session. See how your knowledge is of Pythagorean Theorem. All right, so this is what I got. Number 1, you should have gotten 13. Number 2, 15. Number 3, look, that's where I wanted you to leave it as a square root, so just the square root of 74. Number 4 was 6. Number 5 is 8. Number 6 is 4, 7 is 20, 8 is 9, 9 is 10, and 10 is 13. How did you do? Well, I hope you did well. If you didn't, please feel free to go back and check out the videos again, just so that you can make sure that you know what you're doing moving forward. So you do have some extra practice assignments on your resource document. So that's what you could do next, is to practice a little more of what you're doing. There's a couple of videos and a couple of games that you can learn more about the Pythagorean Theorem. All right, so let's review. Wow, that was a lot of information. How did you do? I hope you did well. Know that you can go back and review at any point. Let's review what you should have gathered from this lesson. So we've talked about how the longest side is the hypotenuse, or side C, and it's always opposite the 90-degree angle. The other two sides of the right angle are the legs, sides A and B, and they're interchangeable, right? Pythagoras developed a formula for finding the length of the sides of any right triangle, and the Pythagorean theorem states, for any right triangle, the sum of the areas of the two small squares is equal to the area of the larger. So that means if I add the squares sitting on the two legs together, I will reach the square from the hypotenuse, right? Not the side lengths, but the area of the squares sitting on the side lengths. And we know the Pythagorean theorem as a squared plus b squared equals c squared. We talked a little about how it might be leg squared plus leg squared because they're interchangeable, right? But the c always has to be the hypotenuse, and it's always the longest side. All right, let's go back to our learning targets and see how you did. So, now, do you know how to apply the Pythagorean theorem to determine unknown side lengths in right triangles? I hope you do. If you don't, go back and check out Pythagorean theorem in the real world to see how you can apply that to real world situations. Can you determine if a triangle is a right triangle? That's one of the first things we did, right? We had to figure out if the Pythagorean theorem made it true or if it didn't and it was not a right triangle. So remember, that happens when you are given all three side lengths. And then solve problems involving the Pythagorean theorem. I hope that you know how to do this. You can solve for a leg or the hypotenuse to figure out the answer. I hope this session and this lesson on solving and learning about the Pythagorean theorem has been helpful to you. For additional practice and support, check out the resources and activities that have been provided in the resource list linked directly below this video. Know that you can come back to this lesson again and again to further reinforce your learning. Reach out to your teacher if you have any questions. We're looking forward to a great year thriving together. Thank you so much for watching.